Alright guys, claim, evidence, reasoning. Let's talk about it. So at first, you're going to get a question that should be provided for you in your resources or by your teacher. You're then going to take that question and then you're going to give me a claim. Your claim is basically going to be your answer for the question that has been presented to you. Old school CREs used to call that your proof, but that gets dicey. So you have your claim. Don't try to give any explanations in your claim. Not yet. Save it for your reasoning. After you have your claim and you answer your question, then you're going to go ahead and you're going to provide your evidence. You should provide your source of your evidence as well, which is important to make sure that your source is valid. Your evidence could be charts. It could be real life, like data. It could be pictures, diagrams that prove your point. Your evidence can be statements from valid places, valid sources. And then at that point, you're going to take your evidence, those cold hard facts, and then you're going to put that into your reasoning. So it's almost like you're going to connect your explanation and your claim, but you're going to kind of tell me how you got there. So imagine it as if somebody is giving directions. You're not just going to say, okay, you need to go to my house. You're going to drive. Then you'll be at my house. You need to give the directions on how you got from point A to point B. That's really, really important. A lot of people get super tripped up on the reasoning and then they just keep restating their evidence, which again, I totally see when people do lab reports or when people do any type of science fair projects. Don't get tripped up on just restating. You're not restating. You're telling me how you got from point A to point B. Really higher level CREs, you're going to talk to me about principles. Okay, so scientific principles to prove basically how you got to that point. So let's go ahead, let's talk about it. So let's do one together. A CRE, right? So I give you the question, why is the sky blue? That seems really easy, right? But I'm going to tell you the number one thing you should do when you get a CRE, break down the question. Break down the question because that is what's going to help you get to your claim, and that is going to super help you figure out what you need to research to find evidence, and then you're going to be able to understand your reasoning more. So first and foremost, I know that sounds simple, why is the sky blue? But what makes something blue? Why do we see blue? So that is your number one hint on why the sky is blue, right? What is the sky made up of? So you need to tell me why we see blue. What is the sky made up of? Because those two things are huge in answering why the sky is blue. Okay? So now we're going to get to, obviously you can't have a real claim. You work a little backwards. You need to do your research, right? I mean, you could try to have a claim right ahead of time, but it's not a hypothesis. Like, you're trying to answer a question. Why is the sky blue? So you're looking for your evidence. So you're going to go ahead, figure out, why do we see blue? And then that's going to talk about basically how your eye interprets different waves that are around you. And then if you're like, waves? Colors are in waves? Like, what? You're then going to have to figure out what that means. So then you're going to go deeper into waves. Then you're going to get into EM waves. Hint, hint, that's going to come back for reasoning. And then you're going to figure out basically why we see blue. We see blue because that is the color that is reflected back to us. It's not absorbed, right? So that's how your eyes basically interpret it. So they decode your stuff. And then you're going to have to figure out, okay, fun fact, hopefully you know this, the sun's not actually yellow. The sun actually gives out white light, which is every color, right? And radiation, super important, different day. But it gives off every color. So why do we even see yellow? And then wait, why do you see the sun as yellow and why is the sky blue if technically all the other radiation that's around you is white? Glad you asked. So when the sunlight enters our atmosphere, it's all colors. It's a beautiful white light, but then all of a sudden it starts bouncing off of our particles in our air, right? So air is matter. It's made up of things. If you filled up a balloon, you kept filling it up and measuring it, guess what? It's going to get heavier, even though it seems like it's not a thing, right? That's how friction works. Okay, so now we know that we see blue light because of wavelengths reflected back to our eyes, and we now know that the air is made up of these particles that light is reflecting off of. All right, stay with me. you can use in your evidence. You could use prisms, which take white light and separate them, because eventually that's why you see colors, is because of that separation. You could talk about EM waves. I would save that though for my principles and my reasoning, but you could even use that as evidence. You could you could even use like little graphs that show how wavelengths work. So let's talk about how wavelengths work. So the shorter a wavelength is, the more intense that it usually is, right? So when it's bouncing off of these particles, longer wavelengths, such as aka red, is not going to bounce off and scatter like a short, intense wavelength like blue. So yes, red is a longer wavelength, you can see it from further away, but blue is this tiny little, like, more intense color that is bouncing off all of these particles. So for us, it reflects back to our eyes as the color blue. That's why the sky is blue. So you can then use all of that, put that in your reasoning. You can even use diagrams if you want of what the air particles themselves would look like. You could even use diagrams of the fact that air is matter. You can then talk about basically how color is reflected. You can use the properties of EM waves to prove your reasoning. And again, we did all of that, and we covered so many concepts in science by just really breaking down one CRE. And again, I know that that sounds like, but it's really important that you research, and then you figure out, and then the more you know. So again, don't just restate, don't get lazy, dissect the question, get in there, do your research, get your evidence, make a good claim, and then connect the evidence and claim and get your reasoning. It's that simple, right? Right? Totally.